Hey everyone, Ryan McCamey and Swapnil Deshmukh here with Certus Cybersecurity. We wanted to take a moment to walk you through a scenario from a recent Capture the Flag event that Certus Cybersecurity's team participated in. The findings hold important lessons for developers and security teams seeking to protect against attacks that take advantage of situations where an application displays too much information to a user. In the scenario we'll walk you through, a seemingly insignificant issue, a verbose error message, was leveraged to identify and exploit more significant issues, ultimately leading to remote code execution, or RCE, a security weakness which can lead to dire consequences. I'll hand off now to Swapnil to walk through the attack in greater detail and help explain how to protect your company against this kind of issue.
Thanks, Ryan, for the introduction. So let's talk about a CTF that we recently were participating in. And the issue that we saw was a very real life scenario that we have seen. So to just give you a quick primer on this application, this CTF challenge had a link that only showcased information between 1 to 4.txt files. So /read/oracle/1.txt would populate a random text like you can see on the screen that I'm highlighting right now. So that was the CTF that was presented to us. However, we tried to simulate some sort of verbose error message. And that's what I'm doing right now by just entering a random text to see how does the application react back to it. And when we entered that information, we got a verbose error message. Now, verbose error message in itself is not a huge risk as such. But what it does is that it provides an end user with a lot of information about the application. And in this particular case, it also provided us with a code snippet of where exactly that error was happening. Now, this information, don't get me wrong, is very, very useful when it comes to understanding what are the bugs within your development environment. However, when it comes to production environment, this information should be completely passed. In this particular CTF, it wasn't, and in many of real life examples that we have seen for Fortune 100 companies, it's somewhat similar. So as you can see in this case, they were basically reading a file path, and that file path append a random integer anywhere between 1 to 5, and it will present that up to the end user. Along with that, this is one of the features that Flask has that allows you to have an interactive debugger rather after you enter a pin. Now, we will look into how we got into the pin in a bit, but then since I know that they're reading the file name, as long as they're not even checking for URL encoding because of the code snippet that I was able to see from the debug information that I got, the first thing that I started doing is I started entering other file names. How can I come out of the existing file directory and go to the server files like etc password, for example? So I looked back at the code. I realized that I required read and then the file name, and that's the path that I was looking for. So as a result of that, I was able to modify, and since I wasn't completely out of the file, I wasn't able to read etc password, but as you can see, as soon as I made changes to the file path, I was completely out of the directory by doing .. and .. which basically brings it back. And then I went to etc password after that. And as you can see from this particular code, I was able to read the etc password file. Now, from an adversary's perspective itself, they now have read capabilities on the server. But keep in mind, they don't have write. It does not have a remote code execution. So that's where, if you remember, previously we saw a pin that was entered, and I wanted to understand how the interactive pin actually works. So I looked at the source code for Flash, basically showcased the information of how they are generating the pin. And RV is nothing but the pin and how it's being computed. So in a nutshell, there are only two main attributes that they're collecting right now. The one is public bits, and another one is private bits. For the public bits, it's the username, mod name, the app name, and the file path. Mod name and file are directly derived from Flash, and username is where we can see it from the password file that we just saw a few moments ago. So we already have all the public bits, and in order to compute the private bits, we need the machine ID, and the source code on how they're generating the machine ID is right up here, which is etc machine ID. With the vulnerability we just found recently, on the CTF, we can crawl to etc machine ID and just derive the machine ID from there. And the other information that we require is the get node. So get node is another Python script, Python function rather, that basically gets the information about the network's MAC address. And it converts that MAC address into int, and it presents that as a string right here. And those are the attributes that are required for computing the pin. So now that I have a complete understanding of what the requirements are, and with the existing vulnerability, I was able to gain all of that information. I came back to the demo in order to collect all of those attributes. One of such is nothing but the MAC address that has been used to get the UUID. And as you can see from the code itself, I was able to get that. And I created a Python script very similar to getpin that had all of that information jotted down on what the machine ID was, what the network interface was. This network interface was from this page itself. I converted that into int, and that's the int version of the UUID, and I'm converting that into string. And after that, how they compute the pin, I copy pasted that exactly as is from the open source code that we just saw. So after running this application, I was able to get two most important things. One was a pin, and another one is the cookie. The pin is the one that would be used for the interactive debugger that we have. So as you can see right there, that's the pin that I was able to generate, and I'm printing it out on this Python script when I'm executing it. So after creating an error message, I can now interact with it and I can test my pin that I just derived from the open source. And as you can see right here, I have the console that is already ready, and I was able to perform any Python scripts on the server remotely, so from my own desktop itself. So that's how just a small finding such as verbose error messages can lead to RCE. Interestingly enough, this has been derived from one of the big firms within China, and we have seen that attack. It's not publicly exposed at this point, but we saw that attack from there itself.